The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.
All right, Ben, so we're gonna do more work on the super glue gun, yeah?
That's correct. Previously, we took apart glue guns and figured out how to control the hot end and sense its temperature. Next, we're gonna work on the extruder motor. I bought a bunch of motors. We're gonna see which one can fit inside of a glue gun for one thing, and then try to push the glue stick through a hot end using a motor and a gear. So we're gonna be using a DC motor controller, trying to figure out how much current that's gonna draw, what kind of power supply it needs, probably 12 volts. So we figured out how to heat it up. Next, we're gonna figure out how to push it through. Let's get started.
Amazing hacks.
Should we take it for a spin?
Inspired designs.
Imhotep's priests.
Regrettable acting.
No one seems to get it.
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
Hey, Mr. Heckendorn, would you like to open this box of Element 14 parts that we just got today?
Yeah, this is for the motor driver part, right?
Motor driver and some other thermistors.
Yeah, we also have some microcontrollers on this list because we want a variety of options when we go to actually design this thing. So we thought about using like one of the 8-pin AT Tinys, but those were too tiny. So we need a larger Tiny.
Yeah.
Which I guess would be a medium. So they have AT Tinys that are 14 pins, so we got some of those as well, along with more TRIACs, basically the cheapest, wimpiest TRIAC that will still work. So what you usually do is you're like, okay, we need 10 watts, so let's plan for 20 watts. So you think high and double it, but then you stop.
Oh yeah, 800 milliamp TRIAC.
Yeah, we noticed that a lot of the TRIACs were either like well under an amp or like 4 or 5 amps. Yeah, I mean, I think a 1 amp TRIAC would probably work. But again, we were looking for the most common ones as well. So we have to find a good balance.
There's an AT Tiny 24.
Oh yeah, here's an AT Tiny. Oh, it's SoC 14. Yeah, let's take a look at these. We have some breakout boards we can use. No, little bitty microcontroller. Okay, so these are the same package, just different powers. So the 20 probably has less flash memory, I guess.
2 kilobytes RAM, memory size, 128 bytes.
Oh, so they're just about the same. And look, like this one's just a little bit slower than 128 bytes of RAM. Ah, that's enough. Hey, that's the same amount of RAM the Atari 2600 had. Hey, maybe we should put these into a bin. All right, so what we're working on today is the gear motor extruder. This would be a DC motor like this. Then when you have a gear motor, it's a motor that has a gearbox built into it when you buy it. So yay, it's like all one unit. So I bought several different types of gear motors. Then I also got a NEMA 14 stepper. Because remember, whatever we build has to fit within the glue gun. And yeah, I mean, one like this might, but then this one, which is probably also bigger than we need, it's pretty beefy. And then one challenge that we were considering is that, we not only have to have a gear motor in there, but we need to have a transformer so we can, take the mains power and knock it down to 12 and 5 volts for the motor driver and the control circuitry. I also obtained 3D printer gear heads, for like moving the 3D prints, like these things. However, one challenge that I found is most of these DC gear motors are 6mm shafts, and most of these are 5. So hey, these 3D printer toothed gears are a pretty common commodity item. So Felix found a little AC DC 12-volt power supply, and we're gonna see if it can run this motor. And then we're gonna set the multimeter to current so we can see how much current it's consuming. All right, ready? Here we go. Well, it looks like the average there is about 40 milliamps. That would have been your startup voltage. Oh, the average is taking into account the low as well. That's why it's so low. The longer we run it, the average would, come up closer to what it is right now. I'm gonna try the holding torque in the meantime. Okay. Which means I'm gonna try to stop it with my fingers. So it's just running dry, but if I put friction on it, it takes more current. Well, anyway, we saw there when I was stalling it, we were getting up to about 250 milliamps. That's still not too bad, which means maybe a little tiny supply like this, maybe that's all we need. I mean, it could be different with a stepper. I guess we'll just have to cross that bridge when we come to it. So what stepper motors can do is, typically one step will be like, it's usually like 1.7 degrees. That'll be one step, but if you have micro stepping, which is done by your controller, you can step up to a 1/16 of a single step. So instead of 1.7 degrees, it'd be 1.7 divided by 16. Yeah, so what you can do is you can have more granularity that way. Like if you're thinking about like a 3D printer, you have to take into account the diameter of your gears and how that affects it. And yeah, if you have microstepping, you can just have finer movements basically. Most 3D printers run their steppers at 1/16 microstepping. In our case, we could probably go a little coarser than that because, you know, we're trying to force glue through a gun. We would rather have more brute force than accuracy. Hey, here's a fun tip. So there's 2 windings in a stepper motor, and maybe you're like, which ones are which? Because there's 4 wires. And what you can do is you can tie them together and then twist it. And if you feel more resistance, then you know that's not the coil you've connected. So, okay, so these 2 are not a pair, which means, just by process of elimination, that the other pairs are pairs. So now if I connect these 2 together, I should feel resistance. See, it's got like a lot of resistance, and if I let go, it's like, woo! Felix found a little supply here which has AC in and then 12 volts and 5 volts DC out. So yeah, it's pretty small, which means we could probably fit it into our unit, or at least, you know we can build something that small. It's probably quite simplified too. So what I'm gonna do is I'm gonna hook up this very large DC gear motor into my meter in serial so we can figure out what the current draw is. Okay, let's go min max. So there's probably gonna be a spike when we turn it on. Go back to a state where we can actually activate it. Yeah, see, it peaked at about 0.5 amp. Right now it's 1.6. So I can see if I can add some friction and see if I can get it to go up. Yeah, see how it goes up once there's friction? I believe this little power supply can do 400 milliamps. So this is more or less within range, except for the spike at the beginning. So that's something we could consider. All right, let's turn this off. I doubt we're gonna use a motor this large. So that's like worst case scenario. More likely, we're gonna use a smaller DC gear motor like this, or a stepper motor. I mean, this DC gear motor is a reasonable size, but the 6mm toothed gear isn't really sharp. That's probably the biggest drawback. Let's see what we got for min-max. It's not too bad, 150 milliamps. 230, 232. We're well below the 400 this thing can supply. I mean, a little motor like this might be a good candidate. The disadvantage of the DC gear motor is that it has a 6mm shaft, and almost all of the commonly available toothed gears for driving filament are 5mm because they're meant to go on a NEMA 17 stepper. So that's the biggest problem with the gear motor, is that we just don't have, this is not as readily available. But maybe it's something we could source. Well, these are gears as well, but they're small enough that they can bite into stuff. This is actually meant to act as a gear, like as to mesh with another thing. Right. Well, you know what we could do is, like, what if we got the pattern for this and we drew up a mechanism so we could have like the idler wheel, like actually build the real thing that will like pull the glue through, and then just see if it works. And then what we could do to simulate a custom gear is we could put this into the grinder sideways to like sharpen up the teeth. I'm gonna take it to the grinder. I measured in the top of the motor, and I've created this 3D printed cap just to make sure we got the measurements right. It's pretty close. It's a little off. I think this opening here needs to be moved in a little bit, but it's close enough to just do this example here. Then I also used the Dremel to manually put teeth onto that gear.
Yeah, this looks pretty gnarly.
Yeah, or gnarly. So this plastic could be part of the glue gun's case. So I'm thinking we have our gnarly wheel here,
okay,
about like that, and then we could extend this and put a idler wheel here. I mean, this skate bearing's kind of big. It might be ridiculously big, although this is like your super standard 7x14mm skate bearing. It's really common and really cheap, although it might be kind of big. We could use one of the smaller ones, although it looks like it's a 4mm shaft. It's less common, although you take up less space. I guess that's a question, like how easy are these to get? Okay, I put together this mess of wires. We have our motor driver here, this very large current sense resistor, the other current sense resistors and capacitors that we need. Got a 12 volt input going for the motors, our logic voltage of 5 volts, and yeah, that should all be hooked up. We could probably drive this with a function generator, or we could just grab an Arduino. All right.
Arduino. There's the function
generator.
generator.
I just need a computer to hook up. I'll grab my laptop. All right, I guess this might not blow up when we plug it in.
Well, let's see what happens.
It's doing something. Hey, it's working. It should do 3 different speeds.
That's neato.
Slow, medium, and fast. What if you had a squirrel and then it died and then you got a new one? It'd be a whole new squirrel.
Oh, it can do it.
Why did it stop?
Maybe having it go through the meters, kind of reducing the amount of current going through.
I think if you have a load feature, it should move at full speed for load. See how it has a hard time grabbing it if it's not already in there at the low speed? Magic marker.
So what have we learned by this experiment here?
Well, we learned that the glue stick rotates. See how the black marks are on the side? What I wanted to see here was just how consistent it was. Although, yeah, as it rotates, it's also not staying straight on this bearing. But it's actually pretty consistent, you know, for such a crude example.
You think we might need a larger bearing or more than one bearing?
No, I just think we need something in front and the back of the glue gun, keeping it straight and aligned. Actually, the teeth marks are fairly consistent. If it was really off or not making a good grip, you know, it would be so marred you wouldn't even see the individual cuts, but they stayed pretty consistent in their distance. Yeah. I think we should rig this up and actually try to push it through a glue gun. Yeah, the pinouts on this board are pretty much the same as that motor controller. It's probably the same motor controller. Well, I mean, I figured we just grab this because it's already wired up for us. I think my robot would be more than willing to sacrifice his guts because he knows it's for the greater good.
Oh, so the greater good.
Yep.
Very good.
What are you doing, Ben? Stop, Ben. Stop. Do you have a pause in there and a break?
No.
Then why is...
There's a delay.
What's happening? Why is it pausing? Right there.
All right, so we had this power supply connected to the microcontroller, the motor driver, and the motor. And we were using a larger motor than we had anticipated, and definitely a larger motor driver. And this smaller power supply couldn't really supply enough current to keep everything running. And the microcontroller kept browning out. So what we're gonna do is switch to a larger power supply. And also, since we have that other motor, Ben is making an adapter, a different adapter for extruding the hot glue stick. So I'm gonna switch the wires over here right now while he does that.
Want to try it again, Felix?
Yeah,
we're still powered up.
Oh
right?
yeah, you got 12 volts right there. A lot of pressure there.
You're saying that it's under pressure? Mm-hmm. Ding, 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 ding. Oh, Felix, this thing will last for 1,000 years. Oh, man, yeah, maybe you're right. Maybe it will break.
Try it. Let's try it.
Ready?
Yeah.
Wait. Ah! All right, go.
Is the hot glue gun still on?
Allegedly. My thumb's having no trouble. File.
So what do you think?
I don't remember this being so difficult before. Not even Joaquin Phoenix could help us with this one. I've run into a stumbling block. Almost all of these DC gear motors have 6mm shafts. And I did find some gears with 6mm shafts. However, they're larger and coarser. Now, gears with finer teeth that are often used for 3D printers, they're much better at grabbing material. However, they're all for 5mm shafts, like this stepper motor. So, yeah, I'm in this bad place of the type of gears that I need, I can't find for the motor I want to use. Now, Karen said there's a place in town where I might be able to order some custom gears, so maybe I can look into that. In today's episode, we worked on the hot glue gun, specifically trying to extrude the glue into the heater element that we worked on in our previous episode.
You weren't doing so well, were you?
No, we didn't really have enough force to move the glue, which is weird. I don't remember that being such a problem before. If only we had the original project.
You know, I was contacted on the Element 14 community the other day by Black Sheep 32, who was the original winner of the Great Glue Gun, the first prototype you made.
Oh, cool.
And he still has it lying around and was nice enough to ship it to us.
Cool, so we could use that to reverse engineer what we did in the past. Because I don't remember us needing that big of a motor. It seems like we're missing something. So in a future episode, we're going to work on the analog trigger assembly to control the speed at which the glue comes out of the extruder, and also try to get the clamp that holds the glue stick working properly.
If you have any questions about the build or ideas for what we could do in the future, let us know on the Element 14 community on element14.com/TBHS.
You can also go there to read about other upcoming episodes, builds, and special events. We'll see you next time. Stick around.
What about the software Wolf of Wall Street? I just felt like being eccentric for some reason. Shut up about Adam Sandler, okay?
he help? Ow! I shouldn't have touched that. Christopher Nolan cannot film action to save his life. I mean, he got better, but the first couple Batman movies, cool as a cucumber. What if you cooked a cucumber? It wouldn't be cool anymore. I will put you into my meteorite chair, Mr. Bono. Little sloth, now it's time for you to poop and pee.
Well, that was charming.
Can you imagine like a sloth that has like not enough fiber in its diet, and it's like, and there's like this little sloth face like. The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.